Hey there guys, in this video we're going to take a look at our lesson on domain values of composite functions. It's just mostly a continuation of the last lesson that we did together where Ms. Schaefer took a look at composite functions with you. It just takes it one step farther and says, okay, that value that you found now, or these values that we're looking at, are they in the domain for what we're looking at? All right, so with this, there are four big types of functions that we're going to take a look at and we're going to work with. They are our linear, quadratic, rational, and radical. And I just want to look over them one more time because I know it's been a little while since we've had a chance to look at them together. So for our linear equations, when we take a look at them, they are going to be usually in this equation. And for our domain, we're looking for how far things go to the left and how far things go to the right. And lines go up and out for forever in both directions. With domain, we're only worried about left or right. But looking left and right, our domain for lines are going to be all real numbers. The other type that we could have and end up working with is going to be our quadratics. Quadratics have something squared in them, where square is the highest exponent that you have to work with. And for these, again, domain, remember, we're looking how far out is this function going to go left and right. And quadratics will go out all the way left and right, all the way to positive infinity and negative infinity. So those are going to be all real numbers. So everything that you could think of and work with can be in that domain. So another one that we can look at and work with are our rationals. And rationals are anything that have a variable in the denominator. And the big deal is that your denominator, this guy right here, whatever is in the denominator, it cannot be equal to 0. So whatever's going on, you've got to take it, plug it in, set it equal to 0, and whatever doesn't work out cannot be in your domain. So if we're looking, and just a friendly reminder of what that graph looks like, whenever we graph 1 over x, we end up with an asymptote or a giant hole in our graph that happens at 0. And whenever you start adding and subtracting things to that denominator, it's going to move it left and right and change where that is. So we've just got to check out and see what's happening there. The last type that we could have and look at is going to be our radical functions, those square roots. And whenever we're graphing things and we're looking at a graph, this is a graph of real numbers. We cannot graph imaginary numbers on our coordinate plane. So when we're looking at our domain has to be greater than or equal to 0. I mean, otherwise we'd end up with something kind of like that. But it's not going to work out that way. So that's what we're looking at working with. Okay. So with that, we're going to use those ideas and move on to our practice problems that we have in the lesson. With these, I'm using the application problems, the choice in the middle. So if you're wanting to work out and try a couple that we talk about right now, then you can do those on your own. Looking at the first one that they give us, the first types of questions that they could give you is they could just give you a number. Like this one just says 2. Is 2 in the domain? So with these, all you need to do is take and plug them in. So remember that whenever you're looking at composition of functions, you're going to plug it into G first, take the answer that you get after you plug it into G, and then plug it into F second. So if I do that, I'm going to be looking at G of 2. So G of 2 is going to be equal to negative 6 times 2 minus 9. So then G of 2 is going to be equal to negative 12 minus 9. So G of negative 2 is going to be equal to negative 21. Let me double check that. That way we don't end up with something weird. So negative 12 minus 9 is negative 20. Okay, good so far. So now I need to take that and I need to plug that into f of x. So now I'm going to do f of negative 21 because we want to take that answer and substitute it into f is going to be equal to the square root of negative 21 plus 3. So negative 21 plus 3 is going to give us the square root of a negative 18. So I'm going to go over here, check the table. And for square roots, we said whatever's inside that square root has to be greater than or equal to 0. So if I look, negative 18, is it greater than or equal to 0? No, it is not. So then 2 is not going to be in the domain of f of g. Looking at our next one. Same idea, except functions have changed up a little bit on us, and now we're looking at negative 7. But I'm going to go through the same process. We're looking at our composition of f of g, so it goes into g first. So I'm going to do g of negative 7 is going to be equal to the square root of negative 7 minus 1. So I'm looking at g of negative 7 is going to be equal to the square root of negative 8. So looking at this, I've got to check before I go and plug it in. I've got to check and see if what I've already substituted in works and will give me a real answer, because if it doesn't, there's no point in moving on. So again, we're looking at our radicals, or we're looking at our square roots. That number has to be greater than or equal to 0, and it is not. So we don't even need to we don't have anything that we can plug into that is a real number to the function f of x. So we can stop there and just tell them that negative 7 is not in the domain of f of g. All right, looking at the next one. For this one, we want to check out 4. So we're looking at f of g, so it gets substituted into g first. So I'm looking at g of 4 is going to be equal to the square root of 4 plus 4. So if I simplify, square root of 4 plus 4 is 8. And I can take the square root of 8 and get a decimal out of it. And just to double check with my table, is this number greater than or equal to 0? And it is. And so if I take this, whatever the decimal would be, and plug it into here, this is a line. And whenever we're looking at the domain of our line, our domain is always going to be all real numbers. So if you're able to have something like this and it works out okay there, and you're taking that and plugging it into a line, it is going to be in the domain of the function that you're working with. Looking at the next one. This has you doing the same thing, except instead of giving you one number and asking you if the one number works, this is, I'm going to give you 4 numbers, 3 of them don't, you have to find the one that does. So you've got to take them and pretty much, until you get a good gist of what does and does not work, you got to take and try all 4 of them out. So if I'm looking at, I don't know, let's start with negative 2. We're still following that same rule. We're still looking at f of g. Whatever is second is what gets substituted in for first. So I'm looking at g of negative 2 is going to be equal to 1 over negative 2 minus 1. So g of negative 2 is going to be equal to 1 over negative 3. That's okay. That does work, because negative 3 is not equal to 0. So that goes okay. So then I need to take that and plug it in for f and see if that's still okay. So with that, I'm looking at f of negative 1/3, substituting it in, is equal to square root of 4 times negative 1/3. So if I simplify that, f of negative 1/3 is going to be equal to the square root of negative 4/3. And so if I go and I compare that to our chart, we're looking at a rational function, and that denominator cannot be equal to, we're looking at a radical, my bad. We're looking at a radical function, and that number inside that square root has to be greater than or equal to 0. So negative 4/3 is not greater than or equal to 0, so negative 2 is not our answer. All right, let's go and check out 1. Let's see if 1 will work. So then we're looking again, we got to start with g first. So I'm looking at g of 1 is going to be equal to 1 over 1 minus 1. So I'm looking at g of 1 is equal to 1 over 0. That denominator in a rational equation is not allowed to be equal to 0. So this one does not work there, so we can stop there. Once it doesn't work, we we don't have anything that we can take and substitute into f of x. So let's try out -4. So I'm looking at g of -4 is going to be equal to 1 over -4 minus 1. So g of -4 is going to be equal to 1 over -5. That works out okay. -5 is not equal to 0. So I'm going to take that and plug that into f of x. So f of -1/5 is going to be equal to the square root of 4 times -1/5. So f of -1/5 is going to be equal to the square root of -4/5. Again, this has to be greater than or equal to 0, and it is not. So it's not going to be -4. So hopefully I haven't made a mistake and it's something else. Well, let's check this last one and see. Hopefully that one will work out okay. So we're looking at g of 6 is going to be equal to 1 over 6 minus 1. So g of 6 is going to be equal to 1 over 5. So far, so good. 5 is not equal to 0, so that works. So then I'm looking at f of 1/5 is going to be equal to the square root of 4 times 1/5. If I simplify that, f of 1/5 is going to be equal to the square root of 4 over 5, and that is greater than or equal to 0, so that one does work out okay. So the answer for that one is, the value that is in the domain is going to be 6. Taking a look at 9. With these, they want to know what's the smallest number in the domain of f of g. So I'm going to do the substitution where I take the g of x and substitute it in for f. With these, they do not give us a number to plug in, so there's nothing to plug in, so we just go straight to, okay, I'm going to take whatever I have over here and plug it into f of x. So I'm looking at what f of g is. That's going to be equal to the square root of 4, and instead of the x, I'm going to write x minus 1, and I'm going to simplify everything. So f of g is going to be equal to the square root of, if I distribute, 4x minus 4, and this is a radical equation. And whenever we're looking at our radical equation, whatever is inside that square root has to be greater than or equal to 0. So I'm going to take that 4x minus 4, set it greater than or equal to 0, and solve for x. So I'm going to add the 4 to both sides. 4x is going to be greater than or equal to 4. Divide both sides by 4. And x has to be greater than or equal to 1. So the question says, what is the smallest number that is in the domain of f of g? And so that has to be 1. So if I type in 1, there we go. That's the smallest number that could be. It can be anything bigger than that. So like we can do 2, 3, 5, 20, whatever you want to do there, and those will work okay. All right, looking at 10. It says let f of x be equal to 1 over x and g of x be x squared minus 3 of x. What two numbers are not in the domain of f of g? Separate your answers with a comma. So again, with this one, they don't give us a number to be able to plug into g of x first. So we can't do that part. So we've got to go straight into the, okay, whatever I've got for g of x, that's got to be substituted into everywhere there's an x in f of x. So if I do that, f of g is going to be equal to 1 over x squared minus 3x. So this type of a function is a rational function. Going back and checking our chart that we have to look at, rational functions, our denominator cannot be equal to 0. So I've got to take whatever I've got for the denominator, set it equal to 0, and see what I end up with. So I've got x squared minus 3x. I'm going to take that and set it equal to 0. So with this one, it's a quadratic. So I've got to use some of our we've got to factor one way or another. So I've got to use my quadratic rules. I can't add the 3x to the other side and then divide by x because we're not allowed to divide by 0. And we don't know for sure that it's not. So we've got to go another way with it. The best way to go with it is by factoring. Both of these terms have an x in them. So we're going to do x times x minus 3 is equal to 0. So now I've got two things being multiplied set equal to 0, so I set them both equal to 0. So x is equal to 0, and then x minus 3 is equal to 0. This one's already solved for. I need to solve this side for x. So I'm going to add that 3 to both sides, and then x is going to be equal to 3. So if we look at the directions, it says what two numbers are not in the domain. So x cannot be equal to 0, x cannot be equal to 3. So, and it says just separate your answers with a comma. So I'm going to go 0, comma, 3. And there we go. Looking at the next slide. We're all done. Hopefully this helps you get through these problems. If you've got any questions or concerns, please email Mrs. Schaefer or I, and we'll be happy to get back to you. Or come see us during our live office hours from 1:30 to 3, and we'd be happy to help you. We'll see you guys next time. Bye.